Okay, guys, so for question 11, which goes with question 10, you're going to have seen the video for question 10 first, for particularly in the time frame where we go over the third step, which is the MCPBA with the cyclohexene that results from the bulky base reaction. And so that's going to explain why the product is the answer that it is, and I'll save that for last. So we already discussed it in the previous, but we're going to go ahead and discuss it again into a little more depth. And that is that after the second reaction, where we use a bulky base on our bromine, our brominated cyclohexane, and we receive a cyclohexene. And then we use MCPBA to form a reaction with the cyclohexene, and an MCPBA is a syn reagent. So what that means is that it's going to give you a cis compound. And I've already put the products here, and you'll notice that they're both cis. In one, you've got the epoxide ring going, the bonds going away from you, and in the other, the ring bonds are going towards you. But you're going to get a 50-50 mixture of each one because they're both cis, and the MCPBA is just going to create a cis product. And then so that plays into, so then now we want the stereochemistry of our product. So the next step in that synthesis question was the acid catalyzed opening of the epoxide ring with hydrogen and water, which is essentially H3O plus as listed here. And so what's going to happen is that 50-50 mixture of the epoxides, which are both cis, are both going to be opened by the acid catalyzed reaction, and it's going to result in two different configurations for the anti-diols. So just as a quick reminder, MCPBA is syn, and then acid catalyzed opening of the epoxide ring is anti. Anti means that we're going to have opposite configurations for the alcohols in our product, and we went over that in question 10 as well. And so both of these, when they're opened, are going to keep the one configuration, but the other configuration, since this is an SN2 reaction, is going to invert the stereochemistry. And so that's why you get the bond going away from you in that case because of a backside attack. And the same thing goes for over here, where you kept that configuration, but in the backside attack, you invert that SN2, you invert the the thing that is added, in that case, of water, which was deprotonated to form the alcohol. And so that's why the answer to 11 is a racemic mixture of R and S. Now, if you do the stereochemistry here, you'll notice that one is RR, the other is SS. I won't tell you which one so that you can practice that. But a racemic mixture is, by definition, a 50-50 solution of enantiomers. And RR and SS are enantiomers, right? And so you can see how if we were to put a plane here, a mirror plane there, this is the mirror plane of this guy, and that's the definition of enantiomers. And so overall, I hope that all kind of came together to make sense as to why the answer here is D, a racemic mixture of RR and SS, and that all stems back from the third reaction in question 10, where we have the MCPBA actually create 50% of both cis possibilities for the epoxide ring.